Good day! Today, we will share our seminal paper that aligns with our program's focus. This paper not only imparts knowledge about the field of engineering, but can also serve as a valuable resource for future endeavors. Allow me to introduce the individuals presenting the seminal paper. Dumo Layne, Esteban Hana, Manipol Hana Nicole, Raquel Renz and Rios Alliah Mhae. We have selected a research paper entitled Examining Influential Factors in the Safe Disposal of Construction and Demolition Waste in Egypt. This paper was authored by ElHassan Reda Ismail, Ghada Mohamed El-Mahdy, Ahmed Hussein Ibrahim, and Ahmed Osama Daoud, and it was published in the year 2023. In the table of contents, we will find a comprehensive outline of the topics covered in this seminal paper. The introduction delves into the historical context of construction and demolition waste, while the abstract offers a concise overview of the paper's core themes. The main body of the paper explores elements such as population, sample, variables, parameters, and statistics, providing essential information for the study's data analysis. Lastly, the conclusion highlights the study's significance for future projects. For the introduction of the study, this will be discussed by Mr. Renz Raquel.
And for the introduction of this study, the construction industry is vital for a country's development, but it faces significant challenges due to the growing volume of construction and challenges due to the growing volume of construction and demolition waste, also known as CDW. This waste poses a threat to the environment and public health, with illegal dumping and inadequate disposal being common issues, not only in Egypt but also globally. The lack of suitable waste disposal sites exacerbates this problem, leading to pollution and endangering nearby communities. The study highlights the pressing need for the safe CDW disposal in the Egyptian construction sector, especially with the government's focus on sustainable development. Automation has the potential to revolutionize the construction industry by improving efficiency and reducing waste. However, previous research has largely overlooked automation's role in ensuring safe CDW disposal. This paper aims to analyze factors contributing to safe CDW disposal in Egypt, addressing a critical gap in the field. The study introduces a theoretical framework for safe CDW disposal based on factors related to waste management, and including route management, illegal dumpings, site identification, and waste tracking. The study goals includes understanding attitude towards illegal CDW disposal, ranking the effectiveness of various factors, and exploring correlation between these factors and safe CDW disposal. The paper begins with a review of automation-based solution in CDW management, outlines the research approach, and presents the result of data analysis. The conclusion offers suggestions for further research in this important area of study. And for the abstract of this study, Rios Alliah Mhae will be discussing.
This paper addresses the pressing issue of safe disposal of construction and demolition waste, CDW in Egypt. It identifies three key factors influencing safe CDW disposal: route management, identifying illegal dumping sites, and waste tracking. The study involved a broad survey of construction industry experts to assess the applicability and effectiveness of these factors in Egypt. The results indicated that factors like selection of the shortest transport route and detection of CDW illegal disposal sites are significant. Moreover, The study found positive statistical relationships between safe CDW disposal and these factors. The research emphasizes the need for a conceptual framework to guide safe CDW disposal efforts in Egypt, incorporating these essential elements. And for the population and sample, Ms. Manipol, Hana, Nicole will discuss the following.
I will be discussing the population and the sample. First, population. The population in the study were professionals from the construction industry and academics with experience in the industry. Next, sample. The sample size for the study was determined using a sample size calculator provided by SurveyMonkey. Since the population was considered to be unlimited, a confidence level of 95% and a confidence interval of 7.5% were adopted. This resulted in a sample size of 133 respondents needed for the study. For the next part, variables, Esteban and Hana will discuss. For the independent variable, often referred to as the cause, is the element that can be intentionally controlled or manipulated. In contrast, the dependent variable known as the effect is influenced by changes in the independent variable. In this study, the independent variable encompass route management, collection, and transportation, as well as identification of illegal waste disposal sites. Meanwhile, the dependent variable represents the outcome, specifically the safe disposal of construction and demolition waste, or CDW.
Level of measurement. The measurement levels are categorized into 4 types: nominal, ordinal, interval, and ratio. Within the nominal category, the following factors are examined. Number 1 is MRCT, which stands for Management of Route, Collection, and Transportation. Number 2 is determination of illegal waste dumping sites. Number 3 is construction waste tracking and scheduling. Number 4 is SDCTW, which stands for Safe Disposal of CDW. Number 5 is GIS for route management. Number 6 is GPS. Number 7 is SENS, which stands for sensors. Number 8 is IP, which also stands for image processing. Number 9 is GIS for illegal waste disposal sites. Number 10 is determination of GIS. Number 11 is FRID. Number 12 is rule-based reasoning, RBR. The ordinal category, the focus is on assessing the level of importance, which is evaluated as high, medium, medium-low, and low with corresponding numerical values decreasing in importance. The interval scale is employed to gauge the extent of agreement regarding the anticipated impacts of safe CDW disposal on Egypt's sustainable construction sectors. The scale is defined as follows. Number 1, which stands for strongly disagree. Number 2 is disagree. Number 3 is neither agree nor disagree. Number 4 is agree. And number 5 is strongly agree. And lastly, the ratio, which analyzes the distribution of respondents in different fields. Their years of work experience specifies that 56% of the respondents were from the industrial field, 29% were from the academic field, and the 15% were from the both academic and industrial fields. Renz, Thomas, Raquel will be discussing the parameter of this study.
And for the parameter, in this study, from the survey's general information section, it was found that 56% of respondents came from the industrial field, 29% from the academic field, and 15% from both. In terms of work experience, 36 had less than 10 years, then 34% had 10 to 20 years, and 30% had over 20 years in industrial or academic fields. When asked about their firm's safe CDW disposal during projects, 41% indicated it's done rarely. 27% said sometimes, 24% said never, 5% said often, and 3% said always. Concerning the necessity of a disposal framework, 72% strongly agree. Then 23% agree, 3% neither agree nor disagree, 1% disagree, and 1% strongly disagree. And for the statistics, Rios Alliah will be discussing it.
The scale used ranges from 1 to 5, with 1 signifying minimal application or effectiveness and 5 indicating strong application or effectiveness. The highest rating on the scale is represented as A or 5 in this study and represent the total number of actively participating respondents. The Relative Importance Index or RII values falls between 0 and 1. The high RRI rating suggests that certain items are more applicable or useful than those with lower RRIs. According to Chen et al., the importance levels obtained from the RRI analysis are presented in tables 4 and 5. The items were ranked twice, once based on their applicability and once based on their effectiveness. In Table 4, you can see the RRI findings along with the corresponding rankings and relevance level based on the item's application. Most items were categorized as high-medium, while the remaining items were classified as high and of high relevance. This data suggests that most items are suitable for the Egyptian construction industry when it comes to safely disposing of construction waste. In particular, selection of the shortest path transport route has a high likelihood of being applicable, while tracking and control of waste from the generation site to safe disposal site has the lowest chance of being applicable. On the other hand, Table 5 shows results for the Relative Importance Index and the corresponding rankings and priority levels based on how effective these items are. 2 items were given a high importance rating, while the rest were rated as high-medium. This indicates that almost every item is considered highly effective in ensuring the safe disposal of construction waste in Egypt. The high priority items have RRI values between 0.809 and 0.803, while the high-medium priority level items have RRI values between 0.768 and 0.698. In this context, detection of CDW illegal disposal sites is the most effective among various factors, and prediction of CDW waste disposal shortest path is the least effective. And for the descriptive and inferential statistics and also the conclusion will be discussed by Mr. Dumo Layne.
Under the results is the descriptive and inferential statistic. The descriptive statistic were utilized ideas to the respondents demographic information in the respondents' scores on the applicability and effectiveness of proposed automation tools towards achieving the safe disposal aspects of construction waste management using RII. Under the results, we used the mean cross-tabulation, frequency, and relative importance index. Inferential statistic. Correlation analysis is used to look at the relationship between IDVs and DVs. IDVs are represented in this correlation analysis by the effectiveness level, whereas the DV is presented by the level of agreement on achieving the desired result of the safe disposal CDW. In this step, the cause and effect relationship between each IDV and DV are scrutinized for the relevance. For the conclusion, Ms. Hana Esteban will be discussing.
For the conclusion, the aim of the study was achieved, as this study added new knowledge by first ranking the various IDVs according to their applicability and effectiveness in the Egyptian construction sector, And second, examining the relationships between the various IDVs and the DV using descriptive statistical analysis. The respondents' demographic data was investigated. Sadly, the majority of respondents' companies did not care about safe disposal of CDW. Respondents also made clear that they firmly agreed that framework is needed to be created to incorporate these elements into the safe disposal of CDW in Egypt. The various SDCDW criteria were rated using the R2 method according to how well they applied to CDCW in the Egyptian construction industry. The item with the highest applicability among the several parameters was discovered to be selection of shortest path transport route, while the item with the greatest effectiveness was detection of CDW illegal disposal sites. In order to determine the cause and effect connection between such IDV and the DV, a correlational analysis was lastly performed. The DV and all IDVs were discovered to have strong positive connections. The next stage in this research suggests employing the structural equation modeling or SEM to conduct a multivariate statistical analysis of the responses to the survey questionnaire. It is useful to test and validate the theoretical framework of various hypotheses and components in a multiple system in order to develop a conceptual framework for ensuring safe disposal of CDW in the Egyptian construction sector. Also, it is recommended to use principal component analysis and analysis of variance to examine the relationship between the factors and the CDCDW.